be 5 equations, 5 unknowns. 6 equations, 6 unknowns. We need an efficient way to do it. So please get a calculator, just go up there, they'll check it out for the rest of the semester for you. And then I'll show you all the keystrokes in order to learn how to do it. If anyone is unsure if their calculator does it, you can come talk to me, and if it doesn't, then you go check one out. I know the ones they have over there will work. Okay?
Do you need a student ID?
What?
Do you need a student ID, or do you just give me a
I don't know what you need, to tell you the truth. Probably a student ID.
Do it with one of the IDs.
You have to email and fill out like
A little thing online,
and you
yeah.
have to wait, I think it's like 2 or 3 days before they send you an email back, and you take that email, you go in there, and then with that email, then you can.
Yeah, so there's a little bit of a process.
Huge form for it.
Yeah. Well, it's not, I mean, it's not that bad. It's free, it's 100, those calculators like 150 bucks, you know? So, I mean, they've got like a tub, like a big old tub of like hundreds of them. So, you know.
Because nobody wants last year's model, so, you know, they just come to the colleges for free.
Yeah, I don't know where they got them from. Somebody's tax dollars. All right, so I'm not going to continue this because we realize we have to solve this system, and I'm not going to go through that. Next class, we can do it on our calculators. Plus, we already solved this using the short way, right? So we don't need to do this. This is just to show you the method of how it's set up. What you try and do is eventually get to a system of equations, and then you go solve the system.
That's what the matrices were for. That was my suffering. Suffering night after night doing matrices.
That's one of the things it can do, that you do with matrices. All right, how about this one? Got to do long division first.
That's fine.
Yeah. Yeah, well, check for u sub would only be if the bottom had the 4 as the power and the numerator had the 3, because you wouldn't want your derivative on the bottom. But it's not going to work. So we've got to do long division first. So let me do that over here. Long division. All right, up top, I need an x to the 4th. I need a plus 0x cubed, because there's no x cubed term there. Then minus 2x squared, and then plus 4x plus 1. And then on the outside, x cubed minus x squared minus x plus 1. By the way, with your denominator, if you were missing an x term in here, anything's missing, you do not need zeros there. You only need the zeros for the numerator one, because you have to create spaces for them, for those positions, right, in the long division process. All right, what do I need to multiply x cubed by to get x to the 4th? X. Okay, now I hit all of those with x. X to the 4th, here to here, minus x cubed. See, isn't it a good thing we have an x cubed here? X times negative x is negative x squared. X times 1 is x. Come through and subtract. Change the signs. Yes?
Why is the x cubed subtracting again?
Y is, well, this times this is x to the 4th, right? This times this is negative x cubed, right? And then negative x squared, and then we're good?
And what are we dividing it by? We're dividing it by the denominator, the bottom?
Yes. All right, we have changed signs, right? Let's not forget, change signs now, subtract. So that becomes minus, this becomes plus, that becomes plus, this becomes a minus. And let's carefully go down here. So nothing. Here to here, we get x cubed. Here to here, minus x squared. And then here to here, plus 3x. Here to here, plus 1. There we go. Okay. Now we do it again, if we can. Here to here is 1, so plus 1. And then we multiply all those things by 1. So you get x cubed minus x squared minus x plus 1. Right, multiplying that by 1 is pretty straightforward because nothing changes. And now, don't forget, you got to subtract, right? So subtract, which changes the signs. And this becomes a minus right there. So we now add down. These go away. Hey, those go away, right? Yeah. Hey, cool. All right, this, 2x. Oh, no, 4x. I almost messed up my own. 4x
Plus 0.
plus 0, so just 4x. Now we do it again. Can x cubed go into 4x? No, so that's our remainder. So here's where we are.
Can x cubed go? Why can't x?
Well, it can't go in without using a fraction. That's what I was saying. All right, so now my answer, or that, all that right there is going to turn into the x plus 1 plus the remainder over the divisor, right?
Do we
Yeah.
expect where it's going to be an easy division on the test, or is there just no way?
Easy, what's easy?
Where there's no remainder?
It'll be easy.
Oh, well, if there wasn't a remainder, then that means that it completely factors and a factor cancels and you don't have a fraction anymore. So you're always going to have a remainder.
Okay.
Yeah.
After the techniques you teach us, will these fractions be easy?
I mean, it's relative. Easy is relative, right? I mean, look at the quiz I gave today. That was easy for some people and it was hard for others, right? So it's all,
It all just depends on how
yeah,
much
it depends on you. I can't answer the question. I'm sorry. I wish I had a better.
How high
Yeah.
should we expect the numerators to be on the degree of the numerators?
Yeah, what's the degree of the numerators? That's a good question.
Whatever I demonstrate in class is about what you should expect, and then whatever you see in the homework is about what you should expect. I won't go crazy at like, degree 10 or something.
So basically,
Yeah.
you should be able to solve this by yourself. This, almost exactly that.
You need to get comfortable with this. I mean, y'all are asking me for details about things. I mean, just sit here and learn, understand the process, and don't ask me about the test yet. You got to learn this first. Then you talk about the test. All right. Where are we? Yeah, we're lost, right? Look, can we handle these?
Yes.
Yes, those two are easy, right? We can do those individually. So I'm going to go ahead and do those now. I have 1/2 x squared plus x, right? Antiderivative of each of those. I have a plus c, but I'm going to worry about that later. Plus this integral that I have not taken care of yet, right? This is still here, and I have yet to resolve what it is. But I at least have chipped away a little bit at the beginning pieces. Now, this is like a new problem, okay? Polynomial over polynomial. The degrees we've already taken care of. There's not going to be long division. It came from long division, didn't it? Yeah. So now what I can do is go straight to the partial fractions now with this. So now I'm going to step to the side again. Okay, I'm going to step to the side. Partial fraction decomposition. And what I'm doing is I'm trying to break down this thing right here, this right here. Now, I'm going to need to factor the denominator. So how do you factor something with 4 terms? Grouping. Grouping. Try group. Now, synthetic could help you factor it as well, but I'm just going to look at it down here real quick. If I do grouping, I do something like try and pull a GCF out of the first two. X squared, x minus 1. And then over here you have to pull something out that makes this also turn into an x minus 1. So negative 1. And that gives me x minus 1 there. So I'm here to remind you of grouping, right? Grouping is something from college algebra. So this is grouping. I'm not done because it's a factoring technique from college algebra. So from here, since these two match, I write down what matches, and then I write the two things that were in front in parentheses. And then I take this, that's a difference of squares. Very important step there, that I realize that's a difference of squares.
It has to be linear, right?
Well, it doesn't have to be linear, but do you see that I have a repeated linear factor in here? I have x minus 1 twice in here.
Okay.
And if you don't do that, if you don't factor that, then you're going to miss that. So when you do this step of partial fractions, you look at the denominator, you have to factor it completely.
So if you don't see that difference of squares, and you just kept going.
Well, you would run into a problem because partial fraction decomposition doesn't tell you how to handle this. Partial fraction decomposition says only deals with linear factors and irreducible quadratics, non-factorable quadratics. This is factorable. So the partial fraction technique assumes you've factored completely. So you have to be careful. So this is grouping. If you need to go back and review that, then, you know, office hours, tutoring, whatever. Here to here, yes.
What was the exact word you used, that partial fraction? What was it?
Partial fraction decomposition.
Yeah, it deals with
Linear, it'll only handle linear and repeated linear factors in the denominator, or irreducible quadratic, or repeated irreducible quadratics in the denominator. It doesn't deal with, if you've left something unfactored, partial fractions is going to actually take you in a circle. So you want to make sure you factor completely. All right, so I factored the denominator. I factored up, sorry, usually we go down. Factored up, right? So now this is my denominator, so I put it under here. X minus 1 squared, x plus 1. Yes?
Could you have just written it as the different squares written, like factored out?
Like this?
Yeah.
Well, yes, but you have to recognize that this is a repeated linear factor so that we can use the process for a repeated linear factor, right? Because there's a process to it. All right, so y'all are going to have to remember that I've got all this here somewhere, okay? So I'm going to continue now. I'll continue over here. 4x over, let's see, x minus 1 squared x plus 1. All right, now I look at the denominator. First, I have a repeated linear factor. So I'm going to need an a on top of x minus 1, then a b on top of x minus 1 squared. Right, that's what I do with the repeated linear factor. Then I have another linear factor. So I put plus what? C over x plus 1. There we go. That's the setup.
it's always going to be addition in between, right?
Yeah, well, A, B, and C might turn out to be negative or something, but we always do it with a plus.
Okay.
Yeah. All right. Next step, clear the fractions. So you multiply both sides of this by this right here. So imagine doing that on the left and on the right. And then do the same thing over here. When I was in Cal 2 and we got to this, my teacher would go from that to the partial fraction decomposition without any work shown, and then just continue the problem, then be done.
Yep.
That entire step was assumed that I could figure out on my own, right? Which is a huge step, right? To go from that to all these little ancillary things we have to know how to do.
And then if you raise your hand and ask about it, they're like, well, you should have learned.
Yeah, this is prerequisite material. So cancel, right? Cancel. But that's what makes this, that's what makes Cal 2 hard, is that it's all those other things you have to pull together, right? So that's why I'm showing it.
And it's not that they wouldn't teach you, but then they would just be like, oh, this is like back on my schedule. I didn't plan for this. And I spent 5 minutes and I have to do 4 questions today.
Okay, that's enough.
Sorry.
All right, distribute. What do I get on that first term? A, and then x minus 1 squared? I thought that's what I heard someone say. X plus 1, okay. So what happens when you go from here to here is only one of the x minus 1 factors cancels. So you're left with one of them and you have the x plus 1. Okay, what about on this next one from here to here? B times x plus 1. So both of the x minus 1 factors cancel. And finally, C x minus 1 squared. I'm really hoping we can do the short one method here. I'm really hoping we can do the short method here. I can? Can I?
A cancels with both of them.
Yeah, so let's see. I'm going to try the short method. All right, so let's try and go after A. Is there something you can do to kill both of these? Without killing the other one, no, right? You can only let x be one thing. So do y'all see I can't get these to both go away at the same time? Shit. Okay, well let's go for b. Can we get b though? B we could get by doing x is 1 here and x is 1 here, right? If x is 1, it will kill both of those and I can get b. Yes?
Wouldn't that be c times x minus 1 cubed?
This is canceling, right? This is on the top and it's canceling. I'm not sure where you're getting x minus 1 cubed from.
Okay, no, I know I did. I know I did.
You sure?
Yeah, I know I did.
Okay.
Yeah.
So we can get b, yes? If we let x be 1. Can we get c? What would we have to let x be over there? Do y'all see negative 1? Negative 1 here would kill that and that. So we can get b and c, we just can't get a. Yes?
Can you do partial short and the rest long?
Yes, you can do a little bit of short and then do the long, and then as soon as you get a, b, and c, you're done. Okay? So let's get b real quick. To get b, I'm just going to do this real fast. To let b, what I'm going to do is I'm going to let x be equal to 1. If I let x be equal to 1, this turns into a 4 equals gone, gone. That's what, 2b? Which means b is 2. Okay, I'm moving through that quickly. Now I'm going to go get c. To get c, I let x be negative 1 to kill off both of those. If I let x be negative 1, that becomes negative 4 on the left side. And then that's gone, that's gone. And what does this become? Be careful. If I plug negative 1 in there, get negative 2 squared is 4. So 4c. So that means c is negative 1. I know I'm working fast, but I'm looking at my clock here. I've got 3 minutes.
And A has to be done long?
And then what?
A has to be done long?
A would have to be, well, I mean, there's a couple of different ways we could do this. We could right now just plug in B here and C here and then go try and solve for A. There's a lot of things we could do, but I'm not going to have enough time to, I think, complete this. Let's do something depressing. Let's plug this into the calculator. Let's plug this into, okay, the original problem, what was it? X to the 4th?
Minus 2x squared plus 4x
2x squared plus 4x
plus 1.
plus 1 over
X cubed minus x squared
minus x plus 1. Right? Okay, so I just typed it in algebraically, and let me see what it does with this. Yeah, okay, there it is. I didn't even do the integral, right? I just typed that expression in, and do y'all see this line right here? See that line right there? When we did long division, we got 1 plus x, right? 1 plus x, or we got x plus 1, didn't we? Yes. And then do you see that this is the partial fraction decomposition? Yes. Right? We've got our, for us it was a, I erased it, but I think it was a over this, and then b over the repeated, yes. And then c over that. Yes. So you can see here from this, a is what? 1. What did we get for b?
We didn't get it.
We got B.
What did we, oh, we got b is 2.
We got the third one, we got the second one, but not the first one.
Yeah, so we got this one and this one, negative 1. So you can see the 2 and you can see the negative 1. And we didn't get the a, but it's 1. All right? So now imagine that we had that integral, right? We have to go. Make it bigger.
You can just control plus for that.
If we integrated this, right? We had already taken care of those, right? We had already done that. We had the 1/2 x squared and the x. But see, this is going to be a natural log. This is a natural log. This is not a natural log, but we know how to do it. This is a basic U sub. Just go back and look at last class. We did something like this. So these are all simple integrals. Now, it took a lot for us to get to it, but now they're simple integrals. All right, so what are you going to do for homework? For homework, you're going to attempt what you can out of this section. We have not done any of the quadratics that are irreducible yet on the bottom. So I don't have my book with me. let me see the assignment. So I would say probably for the partial fractions to maybe look at the first half of this section. Maybe look at like it's 7 through 41 odd. Maybe look at 7 through 21 for tonight. See what or for today and next class. See if you can get your hands dirty with it. Odds. It says odds. Yeah. All right. I told you on the very beginning, the two sections that were the hardest were trig sub and partial fractions. And it's because there's so much involved in this, right? There's so much room for error, right? So
Is that overall for the class? This is as hard as it gets?
it's as hard as the integration techniques get. As hard as it gets is, I mean, I think most people would say chapter 8, sequences and series. I think most people would say that.
So that's why that's after the next test.
Yeah. Okay. All right, y'all have a good day. Excuse me.